Hi everyone. I wanted to run through a couple what we call inverse normal questions. They show up on your quiz and they'll certainly show up on the test, and they are a little bit confusing. I just want to bring up in our notes a couple things that you could refer to. So if you go back to our 6.2 notes, one thing that you might want to refer back to is this part right here where I noted that the words probability, area under the curve, percentile, and proportion are all ways to say the same thing. So if you're ever talking about the shaded region, they might refer to that as the area. They might refer to that as the percentile. They might refer to it as the probability, and it's all of those things. If you want to go back to where we talked about the inverse normal in our notes, you would want to check out question number 7, the very last question we did in 6.2. So they start you out with a probability, or again, another word for probability would be area or percentile, and they want you to work backwards and find those z-scores or find the value along the x-axis. So when we do these, we basically work backwards with that normal calculator. We're going to put a value in the quote answer box and work backwards. So that's where you can refer to in the notes and in that video if you would like to do that. But I'm also going to just show you a couple examples. So this is one question, and I've just pulled up a quiz. And on this one it says, in a standard normal distribution, so what we know from that phrase right there is that the mean is 0 and the standard deviation is 1. So when you pull up your normal calculator, that's the default. So we're going to leave it at that. It says the area to the left of some z-score is about 0.35. What is that z-score? So what they're telling us is they're telling us the shaded area, whatever is shaded, is about 0.35, or that's the probability, and they want us to figure out, where does this line go? Where are we on the x-axis? So what we want to do is we want to come over here to the quote again answer box. This is where the probabilities slash percentiles slash areas go. So we're saying the area is 0.35. We are to the left, so we're going to keep a less than symbol. And we want it to find us this value. Where are we on the x-axis? So this right here will end up being your answer. So that's why it's called an inverse normal, because it's like you're working backwards. You're starting with the answer and working backwards to find this box. So of course what that would match up in this particular case would be this one, which I kind of should have maybe known that one anyway. And the z-score should be to 2 decimal places negative 0.39, it looks like in this case. And I'm not sure that, because I'm split screening it here, I don't think that I can get to where I'm going to check my answer, but that's where what it should be. Another way that you will likely see this are the more word problem type ones, where here it says we've got male body temperatures are normally distributed. Now this is not standard normal, right? So it's got a mean of 98.2. So I can change that. And a standard deviation of 0.7. So when it says what body temperature does he have if he's at the 86th percentile? So why it's so important that you know that those words like percentile is the same thing as area or probability. So when you see that, that goes here. So I want to change this to 0.86 in this case. That's the probability. And when we're working backwards, for us, we always use the less thans. So never change that on an inverse normal. Click compute. It looks like his body temperature is about a 98 point. So I guess you'd have to turn that into a 99 as far as rounding is concerned. And this one would be this image right here as well. So that's the difference. Most of the normal calculators we do forward, where we're given the z-score or we're given the value across the bottom and we want to work forward. But on a handful of them, you're going to want to work backwards. So I hope this video helps clear that up a little bit.